Good afternoon, my name is Carlos Macana, and today I am going to present a review about the new trends on reactive power sharing control for islanded microerids using a cyber-physical approach. So this is our agenda. First of all, we are going to review the reactive power sharing problem. Secondly, we are going to address the conventional solution, that is mainly the solution called Droop Control, an improved version of Droop Control. Next, we are going to address the new trends in reactive power sharing. Following, we are going to introduce a cyber-physical framework to analyze these new trends in reactive power sharing control in order to identify the cyber-physical characteristics of the new approaches. Finally, we are going to present a summary of the advantages and disadvantages of the new strategies. And based on that, we are going to present a new proposal of a synchronous reference frame cooperative adaptive impedance power sharing control strategy. Finally, we are going to present our conclusion and future work. So, our objective in this presentation is show a review about the new strategies of reactive power sharing control using a cyber-physical framework. Secondly, we are going to identify the main advantage of and drawbacks of these new trends. And finally, we are going to propose a new approach or a new strategy in order to tackle with this problem. So, first of all, we are going to present what is the problem with the reactive power sharing. Basically, in islanded mode, we can have microgrid that is composed by 2 or n distributed generators and distributed loads. In this scenario, the load changes randomly, and the distributed generation is connected to the distribution line using line feeders and have a power common point. In this way, if the distributed generators don't have any control strategy in order to share their power, we can fix the reference in frequency and voltage in each distributed generator, and with the line mismatch, that is a conventional problem or a conventional situation in this scenario, we can have a power sharing that could be or could lead to overload operation when the load is changing. Also, this load change can lead to high circulating currents. That is a no good point of operation for the small generators, because can be affect the reliability of the general system. So in this situation, the conventional Droop Control was proposed like a solution that imitates the behavior of the synchronous generator. In this way, the frequency is using like a control variable for the reactive power, and the amplitude voltage is using like variable control or control variable to the reactive power reactive power, using basically two constant parameters that are called Droop coefficients. In this way, the current and voltage is measured locally, and using instantaneous power theory, we can measure the active power and reactive power. With these values, we can fix with this expression or with this algorithm the values of frequency and voltage, and in this way normally we can achieve a stable operation under some restriction in the Droop Control parameters, but we can achieve reactive power sharing, accurate reactive power sharing, but the reactive power is a problem because depends on the inductive line impedance that normally is min-matched. We can have reactive power sharing error. In this way, the gap can be proposed like minimize the reactive power sharing error considering unknown mismatch feeder impedance. This is not an easy problem to solve, and a lot of literature have been approached this problem. Recently, the solutions have some convergence to communication-based strategies. Then these new strategies, that is cyber-physical strategies, have new challenges like cybernetic reliability issues, also robustness under communication failures and restrictions like time delays, and reduction of the communication cost infrastructure. So these new trends can be classified in two main categories. As I told you before, the communication-based strategies are so common, and we are going to present basically three categories of this. And also we have a new proposals about local information-based strategies, basically the synchronous reference frame impedance. In general, all of these categories have common characteristics like virtual components inside the algorithms, and also communication infrastructure for in different architectures, but in general are using communication infrastructure. So the first trend is